In just 13 minutes, let's create and manage inscriptions using Particle's Smart Wallet as a Service. Earlier this week on Tuesday, I posted a thread diving into the process of using a smart account alongside Wallet as a Service to create PRC20 tokens or inscriptions. It's actually quite simple, and by using account abstraction for the creation and management of inscriptions, you can basically have users inscribe things without paying any gas fees. And of course, doing so in an account that's generated through their social login. So far from everything that I've seen, inscriptions are pretty cool and they have a lot of cool use cases, but the user experience still has a little ways to go before it's parallel with some of the more developed verticals of Web3. The goal here is to leverage Smart Wallet as a Service, which is the intersection of account abstraction and MPC TSS-based social logins, to significantly lower the barrier to entry required for users to inscribe things on chain. This entire process can be achieved in around 100 lines of code in total to create a demo application. So today, in just 13 minutes, we're going to go through the process step by step of creating this demo application, showcasing the utilization of Smart Wallet as a Service to manage inscriptions on Polygon. So essentially, the application that we're going to be building is going to be quite simple. We're basically just going to onboard a user through either their Google or Twitter account. Then we're going to assign them a smart account. For this example, that'll be a simple account. Then using that smart account, we'll create a custom PRC20 token using an inscription and send it to our MetaMask. So we're going to format this into basically two different parts. The first will be index.tsx. This is where we can configure Particle Network itself and initialize the SDK for app.tsx, which will contain all of our primary application logic. So let's start here with an index.tsx. Let's begin by importing a few different required libraries. We can do React. We can also do React DOM. And from Particle, we can import Polygon from @particle-network/chains. Then additionally, we can import auth core context provider, which will be our main configuration object. And that'll be from @particle-network/auth core modal. Then finally, we can import our main app component, which we'll build in a moment, from ./app. Okay, now to configure Particle Network, we're basically going to be using auth core context provider to wrap our main app component and establish some core configurations. So let's do this within React DOM .create root. That'll take document get element by ID, which we can pass root into, and then we can cast that to type HTML element. Then we can call .render and open it up here. Now let's start by opening a React.strict mode tag, and then within here we can do auth core context provider and define options. Within options, we can establish all of our parameters, the first three of which are the only required ones, which are the project ID, the client key, and the app ID. These are three values that we require for every Particle SDK, as they connect your application directly to the Particle dashboard. So to retrieve the project ID, client key, and app ID, let's first head over to the Particle dashboard and create a new project. All right, as you can see, I'm now on the Particle dashboard. I'm gonna go ahead and click on Add New Project, and I'll name this Inscription Demo, then click Save. Within Inscription Demo, as you can see, we have our project ID, client key, and server key, along with a variety of options here on the sidebar. Within the dashboard, we can do things like customize the authentication and transaction interface, access and fund the paymaster, open the bundler docs, and even create and manage RPC nodes. Although for this example, we want to stick with the applications menu right here. And as you may notice, we're missing the app ID. So to retrieve this, we first need to go ahead and create a web app. I'll again name this Inscription Demo, and then I'll throw in the domain, which I'm hosting the application right here. Although if you haven't gotten to the stage yet where you've deployed the application, you're still working on localhost, then don't worry, feel free to throw in any filler domain here, and it'll still work perfectly. All right, so now I'll go ahead and click on OK, and here we go. I'll copy the project ID, the client key, and the app ID. Now I can throw those into environment variables within my application and move on. So let's begin by establishing the project ID as process.env.react app project ID, along with the client key and the app ID. Okay, so now with these established, let's move on to our two groups of optional configurations, which is ERC437 and wallet. Let's begin with ERC437. Within here, we have two parameters that we need to fill out. The first will be name. This will be the name of the specific smart account implementation that we'd like to assign to the EOA generated by social login. You can choose between either simple, Biconomy, or CyberConnect. Then I'll set the version to 1.0.0. Now we can go ahead and open up wallet, and then within wallet we can begin by setting visible to true. Now by setting visible to true, basically what I'm doing is telling the SDK to include a little particle logo within the bottom right of my application that will act as a pop-up for the wallet interface. So this allows the users to interact and use the wallet directly to do things like sending, receiving, viewing their tokens, NFTs. Although if you'd like to leave this as false and omit that from your application, then feel free. Although because we're setting it to true, let's also set custom style and specify support chains as Polygon. This means that only Polygon will be available as a network within the wallet modal. And there we go. Go ahead and close this off by throwing in our main app component. So we've imported all of our base libraries and configured Particle Network through auth core context provider. Okay, so now let's go ahead and build out our main app component. To begin here, let's also go ahead and import a few different base libraries, such as React, along with useState and useEffect. And then from Particle, we can import three hooks that will basically allow us to interact with Particle as well as the application itself. So this will be use Ethereum, use Connect, and use auth core. That'll be from app particle-network/auth core modal. Then additionally, we can import Polygon from app particle-network/chains. Then on the account abstraction side of things, let's import a wrap provider, smart account, and send transaction mode. That'll be from app particle-network/AA. Then let's import ethers as well as notification from anti. Then we can close it off by importing our CSS. Okay, so now with all of these imported, let's begin building our main app component. We can do this with an app, and then we can go ahead and open it up. To begin, let's go ahead and define functions from those 3 different hooks that we imported from auth core mode. The first will be provider, as use Ethereum, as well as connect and disconnect from use connect, and then finally user info from use auth core. Then let's go ahead and quickly set one state of balance and set balance as use state and null. We'll be using all of these hooks and the state in a moment within our various different functions. So now probably one of the most important parts of this application is establishing our smart account object. This will basically determine, once again, what implementation we assign to particle auth, and this will allow us to actually use account abstraction within the application. So we can call this smart account. That'll be new smart account, and then we can pass in provider. Now in here, similar to auth core context provider, we can define our project ID, our client key, and our app ID. Now we can define the specific smart account implementation that we'd like to use within AA options. And like I mentioned, within this example, we're going to be using simple account, although we can do either simple, Biconomy, or CyberConnect. But in this case, I'll be sticking with simple. Now within here, I can set the chain ID to polygon.id and the version to 1.0.0. And there we go. That's our smart account object complete. Now we want to use the smart account object to actually establish a custom ethers provider that we can use in a moment to do things like retrieve the balance and of course send the inscription transactions themselves. So let's call this custom provider and set it to new ethers.providers.web3 provider. And then within here, we can pass in new AA wrap provider, which itself will take our smart account object along with send transaction mode.gasless. Then we can also throw in any. Now by adding in send transaction mode.gasless, we're basically telling the SDK to send all of the transactions through Particle's verifying paymaster. And now because this is on mainnet, to sponsor those transactions through the paymaster, I need to head over to the paymaster menu on the dashboard and deposit some USDT on either Ethereum mainnet or BNB chain. Then I can optionally set some conditions under which the transactions are sponsored. But in this case, I'm going to leave it as all transactions that pass through this provider object right here will be subject to sponsorship. Okay, so now with our custom provider set, let's move on to creating our 3 main functions within the application. First of which will be basically fetching the balance of the user's smart account and displaying it on screen. To begin, let's first open a use effect. And within here, let's check the condition of user info, basically checking if user info is defined or not, because if it's not defined, that means that a user has not logged in. Although if it is defined or if it's truthy, that means that a user has logged in and thus we can pull their balance. So if a user has been logged in, then let's call fetch balance, and we'll be writing this function in just one moment. Now let's go ahead and make this use effect dependent upon the status of user info. Okay, so now let's write the fetch balance function. Within here, let's start by pulling the address as await smart account.get address, and then using the address, we can define balance response as await custom provider.get balance, and then throw in our address. Now we can set the balance state with set balance, although balance response is going to by default be in a way format, and way isn't very human readable, so let's go ahead and convert this to ether with ethers.utils.format ether. All right, so now with our logic to fetch the user's balance defined, let's move on to the latter 2 functions. The first of which will be handle login. This will take one parameter called auth type, and essentially handle login is going to handle the actual logic powering our social login functionality, which will allow users to sign in and create an account with either their Google or Twitter account. So within handle login, let's also check the condition of user info, although in this case, we actually want to check if user info is not defined. So if a user has not logged in, then we can continue and call connect. Now within connect, let's set the social type as auth type, then we can set the chain to Polygon. And that's it. Whenever we call handle login, we'll be checking if the user is already logged in. If they aren't, then we're calling the connect function with our preferred authentication type and of course on Polygon. So let's now go ahead and create our last main function, which will be followed by 2 supporting functions. This will be execute transaction, and this will take one parameter called data. So first, before we build this, let's establish some quick context. Essentially, using smart accounts to inscribe things directly on chain is very difficult because smart accounts are smart contracts, and inscriptions require you to send a transaction to yourself with the required call data to be picked up by indexers and thus inscribed on chain. Now, in a lot of cases, when you try to do this with smart accounts, this will generally result in a reverted execution, and thus you can't really do it. Now, there are some solutions to this, especially on the contract side, but for now the easiest way to get around this is by using these smart accounts as a sort of conduit for creating or minting these tokens and then sending them directly to your owner EOA address. So in this case, that can be your MetaMask. That way you're still reaping the benefits of account abstraction with things like gasless transactions or even session keys, but you're still owning the actual inscriptions within your primary EOA address. So to do this, let's first define signer as custom provider.getSigner. Then I want to establish our transaction within TX. This will take 3 main parameters. The first will be 2, and I'm going to be setting 2 as my MetaMask address right here. Then we can set value to 0, because again, this is just call data being inscribed on chain, so we don't need to send any matic in this case. Then we can set the data to ethers.utils.hexify, then pass in ethers.utils.2 UTF-8 bytes, and then data. So then this transaction will send basically just call data to my MetaMask address. And of course, for this application, we're going to be making that call data the required inscription data to create a PRC20 token. All right, so let's now send that transaction within TX response and do await signer.send transaction and pass in TX. Now let's also pull the transaction receipt so that we can get the transaction hash within TX receipt. And we can just simply do await TX response. So we can use TX receipt within notification.success and set the message to txreceipt.transaction hash. And that's it for execute transaction. Although within this application, we want to create 2 functions derived from execute transaction. This will be create token and mint token. Create token will deploy a brand new token, and mint token will mint an existing token. So let's begin by defining create token. And within here, we can just simply do execute transaction and pass in the call data that we need to deploy a new token. In this case, that call data includes the type of token, which is PRC20, the operation, which is deploy, the ticker, which is TBSCO, the maximum tokens that exist, and the limit of tokens that can be minted by one person. Let's do something similar with mint token and also call execute transaction. Although instead of a deploy operation, we're doing mint, and we're minting 10 tokens with the amount of 10. All right, and that's it. All we have left to do is structure all of this within our JSX by opening up a return statement and creating it here. Although within these videos, I skipped this part because it can take quite a while and be pretty repetitive. So I'm gonna go ahead and get this written and then come back. All right, and here we go. As you can see, we're just checking the condition of user info. If a user has not logged in, then we're throwing our sign in with Google button and our sign in with X button, which are both mapped to handle login. Then we display their name, their balance and matic, as well as our 3 buttons, create token, mint token, and logout. Logout is just simply mapped to disconnect, which we defined up here. All right, so let's go ahead and close this out with export, default, and then app. And now we're ready to run the application. So let's give it a try and see if it works. And there we go. We have our 2 buttons, sign in with Google and sign in with X. Let's go ahead and give it a try by signing in with Google. I'll go ahead and select this account right here. And as you can see, I have 0.1 matic and our 2 buttons here. We also, of course, have the wallet modal, which we can also use to check the balance, the NFTs, even do things like swapping and bridging and so on. Okay, so let's first give create token a try. And we have the confirmation right here. So I'll go ahead and click on confirm. And there we go. Looks like it was successful. And now I also want to test the mint function by clicking the mint token button. And then same thing here. I can go and click on confirm. And there we go. Okay, so let's head over to my MetaMask account and check if I received the deploy token as well as the mint that I just initiated. As you can see so far, I've received the deployment of TBSCO. And there you go. We have the mint of 10 tokens. And if I head over to my balances here, we can see I have 10 TBSCO tokens. Inscriptions are really interesting. The potential use cases for this span pretty far. And of course, we're here to support this vertical as it continues to grow and evolve. For applications leveraging inscriptions, one of the best ways to get users started is through social logins combined with account abstraction to facilitate completely gasless transactions and seamless onboarding. To learn more about Particle and our tech stack, including our smart wallet as a service, Intent Fusion Protocol, BTC Connect, and so on, then I'll have a full article covering everything that we do linked below. Additionally, if you'd like to try the demo that we made today, or if you'd like to try our main web demo, then I'll have both of those linked below.